Hi everyone, this is video number 2 of the Regents chemistry curriculum. In this video you will learn how to separate mixtures using different separation techniques. Read the following statements, pause the video, read the following statements, see if you know whether the following statements are true or false. If you don't know, that's okay. You should be able to know whether they're true or false by the end of this video. Alright, so there are two different types of separation techniques. There's one chemical separation technique, and there are a bunch of physical separation techniques. Okay, electrolysis. Okay, so electrolysis, let's take a look at what electrolysis looks like. We go on Google, we go to image search, and here's electrolysis. We use a battery. The battery has a positive end and a negative end. The positive end of the battery connects, the blue line, you see the blue wire connects with the test tube that is going to attract the negative oxygen ions, while the negative end of the battery will connect with through the red wire, will connect with the test tube that is going to attract the positive hydrogen ions. So that is simply electrolysis in a nutshell. Evaporation. So if you have a container that contains salt and water, you can evaporate the water, turn it into gas, and then the salt will remain in the container. Distillation. Okay, so the best example would be a mixture of alcohol and water. So if you have alcohol and water, alcohol has a lower boiling point, meaning it will turn into a gas at a lower temperature. So alcohol will evaporate first and make its way. Let's take a look at a distillation picture. Here we go. So here you'll have a mixture of alcohol and water. You'll heat up the mixture. Alcohol, with its lower boiling point, will evaporate and turn into gas, make its way up the column, and then eventually will make its way into the condenser. The inner tube of the condenser, where it will turn to liquid. The way the condenser works is that it has an inner tube and an outer tube. Here I'll highlight it in red. The outer tube is where water comes in and out. Cold water will help bring the gas particles back together and turn them back to a liquid that is collected over here. So since alcohol had the lower boiling point, alcohol has evaporated and then was condensed over here where you got pure alcohol. Water was left in this container, and alcohol is now in this container. If you have salt and water and you don't want to lose the water, you can also perform distillation. The water will turn into gas, make its way up the column, and eventually will condense down here, and the salt will remain inside this flask. All right. separation funnel. What are immiscible liquids? They are so when separating oil from water, okay, so take a look at a picture of a separation funnel. Go Google, click on images. This picture comes up by GCSE Science. We see here we have oil and water. So water is less dense than, water is more dense than oil. So water will make its way down the funnel. You'll open the valve. Water will come out. And as soon as all the water is drained down from the bottom of the funnel, you can shut off the valve and then flip this valve upside down and the oil can come out of the top. That's pretty much it for separation funnel. Chromatography, also a physical separation technique. It separates mixtures based on their, not speed, particle size. Particle size. So, smaller particles will make it far into a medium, such as a gel medium, while larger particles will barely make it through a medium. So taking a look at an example of chromatography. Here we have a medium. We will load the sample of different colors. Here, red has the smallest particle size, so it makes its way the furthest into the medium and eventually is drained out. Green, medium particle size, eventually drains out, and then blue will eventually also drain out. Next is filtration. Okay, so here's an example of filtration. You will need a funnel to perform a filtration. So here's the funnel. The funnel will also have a filter plate paper. Here's the filter paper on top. Very large particle sizes will not make it through this filter paper. Dissolved particles will make it through the filter paper. So dissolved salt will make it through with the water, while the sand, very large particles, will get stuck on top of the filter paper. Lastly, a magnet. You can use a magnet to separate iron filings from different mixtures. So obviously a magnet will be able to attract iron. This is pretty much it for separation techniques. Let's go back to the questions. You can pause the video to answer the following questions. Determine whether the following statements are true or false.